Welcome to the sixth homework of the data science. In this homework, we are going to do lab 3.5, 3.6 Amazon SageMaker generating model performance metrics. And in this lab, we will evaluate the model that we trained in previous labs and calculate metrics based on the result of the data. In this lab, objectives are use the test data to generate predictions, generate a confusion matrix from the result, generate performance metrics for the model, and in here we're gonna starting accessing the notebook instance in Amazon SageMaker, opening the notebook, and in this calculation, yeah, basically we are going to the generating model performance metrics, and I'm gonna start the lab. After it's created, I'm gonna restart the video recording. Okay, the lab 3.6 has been opened. There's a cheat sheet. Yeah, it gives some manipulation list, tuples, dictionaries, and basic stuff. If you go to the 3.6, okay, in this business scenario, work for a healthcare provider and want to improve the detection of abnormalities in orthopedic patients. You are tasked with solving this problem by using machine learning. You have access to data set that contains 6 biomechanical features and target of normal or abnormal. You can use dataset to train an ML model to predict if a patient will have abnormality. And about this dataset, the biomedical dataset is built by Dr. Henrik de Monta during a medical residence period to group of applied research in orthopedic or orthopedics of the center something in France. The data has been organized in two different but related classification tasks. Uh, First task consists in classifying patients as belonging one of the three categories: normal, dyschondria, and syphilitis. For the task, categories dyschondria and syphilis were merged into a single category is labeled as abnormal. Thus, the second text contains in classifying patients as belonging to two categories, normal and abnormal. And there's some attribute information about these biomechanical attributes. And to lab setup, okay, importing data and training model. Let's import the data in here, and yeah, I have to run this one. And actually, I just want to run something in here. Uh, should I action on it? It must be display something after it's run, isn't it? Yeah, it has been run. Not a plan escape defaults from location. Let me rerun it. Let me. After this run, I'm gonna run this one. I will stop the recording while I'm waiting. Yeah, okay, it has been run. There's our values in here and separated face. And I'm going to here and running this one for the test data. Okay, let me run the other stuff. Yeah, this will give the within the 0.3 threshold. If it is bigger than the 0.3, it will return 1. And for the first 5 of them, it's gonna print the data. And in creating confusion matrix, this is actually one of the keys measuring a classification model's metric performance. It's a table that maps out correct and incorrect predictions, and if it's a normal, and the AI says it's normal but it's an abnormal, it is an abnormal but says normal, and it's an abnormal but says, yeah, this is the whole abnormals, this is the whole normals, and this is the, so this is the true positives, this is false positives, false negatives, and true negatives. In here actually, is that why it doesn't has been run? Yeah, okay. Where are we now? Okay, it's running still, I guess. I'm not sure. Okay, let me run this one. Yeah, I will run all of them. Then I'll wait for the working on it. Okay, it says, yeah, this has been run, but I'm not sure about why it has not run the. Yeah, okay, it's run now. Test data. Okay, the test data is here. So if we change the threshold, then our confusion matrix could be changed, and probably it will change, and it's just displaying the how's the confusion matrix. Actually, and for the, yeah, as I said in here, the true positive, false negatives, and true positives in here. And the sensitivity is also known as a hit rate, recall or true positive TPR. It measures the proportion of the actual positive that are correctly did identified. In this example, the sensitivity is probability of detecting abnormality for patients with an abnormality, and this is calculated with the true positive divided by true positive plus false negatives times 100. And in this scenario, it's like a 90%, and actually this is a good sensitivity. 90% is a high actually, and in the specificity is a 70%. For me, actually, it's a good, I guess. But it says too low. Actually, it's a good for me, but it's not so good. For the precision or positive predictive values portion of the positive values, it's calculated by the true positive divided by true positive plus false positive times 100. And within this precision, it's given in here. Actually, it's a good value. And this is a true negative divided by true negative plus false negatives in here. This is the negative predictive values. It's 770 point. Actually, this is okay. And actually, the false positive rate is high for me. I mean, when I high, it's a bad thing because chance that positive result is incorrect, and 9.5 chance that get negative result is incorrect. Actually, this is a good thing, and this mean is false negative mean is actually it's a norm abnormal, but says it's abnormal, and we are dividing it to the that value within the it's actually the wrong answer for the false negatives to the whole wrong answers. No, true answers. Sorry, this is true answers, and false negative is the wrong answers within the abnormalities. And overall accuracy calculated by true positive plus true negative, and with all of them. So this is the true answers divided whole answers. And if we give this one, actually this is really good for me. And calculating the outgrowth curve, the skid-learn grabber has function that helps you to compute the area under the retrieval operation characteristic. The rock is a probability curve. AUC tells you how well the model can distinguish between classes. The AUC can be calculated, as you will see in the next step. It can be used to measure the performance of the model. In this example, the higher the AUC, the better model is at distinguish between abnormal and normal patients, depending on the values. Threshold can change, and probably instead of converted classes. And in here, there's some test labels given for the AUC, and the log plotted with the TPR against the FPR, where the TPR is on the U-axis and FPR is axis on X axis. Skitlearn has the log curve function to help generate those values to pilot. And there's our curves or AC curves. And thanks for the listening. Have a good day.